In this second video in the series, we're going to go through the process of setting up a slightly more complicated robotic machining cell. So we go back to Machine Maker, and once it's booted, I am going to, instead of just having a single robot arm with a single turntable, we're going to introduce a couple of other external axes as well. Most notably, we're going to have a rail system. We're going to be mounting the robot to the rail, and we're also going to have turntable as well. So, first things first, I am going to go up to the mechanisms library, and I am going to search under rails. We're going to go through the online repository, of course. Now, because I've been working with KUKA stuff previously, might as well continue in this case. So we're going to choose the KL1002, which is a rail with a 1 meter range of motion. We're going to click on Add, and we can see how that's just been deposited straight in. Now, I would quite like to choose a robot to fit onto this. So still in the mechanisms library, we're going to move over to robots, and I am going to choose a KR60. So we'll go with the KUKA KR60-3. And we click Add. Now, this is the time when the control drag method works absolutely perfectly for orienting and positioning things, because if we do so, we can see that not only do all of the coordinate systems get highlighted in this, but as we click and drag the robot and drag it near to the coordinate system, this green arrow appears, which means that it's possible to snap the two together. So in doing so, I release the mouse button and it snaps into place, perfectly aligned with the coordinate system of the rail as well. I am, however, going to make a slight change to the positioning of this robot. So I am going to rotate it by 90 degrees. No, sorry, I'm going to rotate it by minus 90 degrees. Because the main reason for this is it gives us the freest range of motion possible. Because behind the robot now we have the cable train for the linear rail, which obviously we don't really want interacting with the robot whilst we're trying to machine something. So we've now got that established and in place with the robot facing away from the cable train. Absolutely brilliant. The next thing we're going to do is we are now going to include a turntable. So we go back to the mechanisms library. And because we've had the KP1 500 before, we might as well go with it again. So I'm going to click on Add, and I am going to move it to where are we going to move it to? We are going to move it to around here. So let's just set that to 1600 in X and minus 600 in Y. So that's quite nicely aligned with the end of the end of the rail, and it means that we can quite easily access any piece that needs machining from this side of the turntable without fear of any kind of impact or crossover or anything. However, since we've got this rail at our disposal now, it means we can potentially set up another working zone. So let's go with that. Let's set up another turntable, but this time we're going to position it at the other end of the rail. Now, this might seem a little bit much initially, but it's actually a very, very good way of being able to capitalize on the room that's available in the robotic cell. And this sort of cell is indeed made use of in many professional working environments. But it also serves to highlight that we can set up as many coordinate system bases as we want. We can switch between each of them in ENCY without any problems, and we can set the job up on both of these turntables that can be two parts of the same job. We can have the whole thing set up in one go, run all the programs, leave the cell working throughout the night, for example, without any problems. So the next thing I'm going to do is I'm going to go back to the simulations page, just because we want to make sure that the ranges of motion are not a point of concern. I'm going to enable collisions detection now, so that will take a second to process. And we can see now that that's finished processing. So first off, we can demonstrate the rail motion, and we can see that sweeping through the full extent of the rail. We can demonstrate the two different turntable motions, and you can see here how they've all been sequentially named as well. So we've got E1 for the rail, we've got E2 for the left turntable, and E3 for the right turntable. And now if we move the rail to the 600 mark, which is its center line, and then demo the motions of the robot, we can see that aside from the crashes that we can obviously see coming, such as it trying to hit the floor, there's literally nothing to worry about with this. Obviously, we've not decided on an end effector yet, so again, we can go through the same process of adding a spindle motor. But the purpose of this video is mainly to illustrate just how easy it is to set up a viable working cell with multiple external axes already accounted for, no tripping up, everything has its own particular priority defined. In the next video, we're going to be covering the process of bringing in user-defined geometries for setting up external axes.